2368 reachable nodes with restrictions. So we are giving n nodes from 0 to n-1 and n-1 edges. And we are also giving a 2D integer array edges. So this edges of length n-1 and ends I just means from AI to BI. Yeah, and you should know that it is undirected tree. Yeah, you are also giving an integer array restricted, which represents the restricted nodes. So this means like the node 4 and 5, that is restricted. That means whether you're gonna use DFS or BFS, the 4 and 5 will not be visited. And we are going to return the maximum number of nodes you can reach from node 0 without visiting a restricted node. Yeah, so this is a straight DFS or BFS problem. We just need to consider those restricted nodes. Yeah, so for example, from 0 we can go to 1, 2, and 3, but we cannot go to 4 and 5. So in total, there will be 4 nodes maximum. So we're gonna return a 4. Yeah, so 0 will not be a restricted node. Yeah, we should note about that. Otherwise, we have to check it first. So this means we don't need to check. Yeah, because 0 will never be a restricted node. Yeah, so what are we gonna do first? We just build a graph first because we need an adjacency list. So for UV in edges, so because it is undirected, so we're gonna prepare an undirected graph. Yeah, so gu.append v and gv should dot append u. This is the adjacency list. Now we're gonna prepare a queue. It should be equal to the queue, and inside it's gonna be the starting node. It's gonna be 0, and also we're gonna prepare a weighted set. It's gonna be it's gonna be set from 0. Yeah, even though 0 is not weighted, but we need to put it inside. Put the 0 inside our weighted set. Why? Yeah, because we are going to start from this node. So for my template of BFS, I'm gonna put it inside the weighted set first, and then I'm gonna check the restrictions. So for R in restricted node, so the weighted set should also end this restricted node. Yeah. Now we can start the BFS. So while Q, we're gonna pop out the node, use q.pop left, and we're gonna check the neighbors. And currently, we're gonna use a result plus 1 because we are calculating how many nodes that has been visited. Yeah, so the result should be starting from 0. Now we are going to check the neighbors. So for neighbors in G node, if this neighbor not in weighted set, so this means the weighted set would add this neighbor, and the queue similarly would append this neighbor. So this is the entire code. As you can see that it is not so long. If this 0 will be in weighted set, for example, in weighted node, in restricted node, yeah. So here set not. If it is in, so we're gonna check it first. So if it is inside, we're gonna return a 0. So, but we don't need to do that because 0 will not be a restricted node. Yeah. So here we prepared the graph. Here we prepared the queue and weighted set, and then we're gonna start the BFS, and then we're gonna record the result. Let me just run it to check. Yeah, so what is wrong? Yeah, gu.append v. This is the strings. Yeah, because inside it should be a list. Yeah. Now let me run it again. As you can see, it works. Now let me submit it to check. Yeah, as you can see, it's pretty fast because the time complexity is just BFS. It is the number of nodes, and it is 10 to the power of 5. Thank you for watching. See you next time. Yeah, I'm sorry. I think the BFS, it is the number of nodes and edges. Because we are preparing this adjacency list, we're gonna visit each of the node and each of the sides. So it is not this n, it is e plus v. It's this n plus v. N plus e. E is the number of edges, v is the number of vertices, so the time complexity would be just e plus v. Yeah. Thank you for watching. See you next time.